first thing I want to start talking about in this Math 150 class is graphing. We're going to be graphing on the XY coordinate plane. I'm going to be graphing a lot of things before this class is over. We're going to start off with some easier graphs, and that is the graphs of linear equations. Linear equations in two variables are equations that can be written in the form ax plus by equals c, where x and y are variables, meaning we don't know what number they represent, and where a, b, and c are constants, just numbers in the equation. If we can write an equation, a linear equation, in the form ax plus by equals c, then we can write it in what is called standard form. Standard form contains x and or y, not necessarily both. It could be both, but it has to have one or the other. And the exponents or the powers on your x and y must be 1. The solutions for any linear equation are all pairs of numbers x comma y that make the equation true. So for instance, is 5 comma 7 a solution to the equation 4x minus 3y equals -1? Well, when we look at an ordered pair, the first number always represents our x, the second number represents our y. So all we have to do if we want to know if an ordered pair is a solution to an equation is take each of these numbers, plug them into the subsequent spots, work it out, and see if the equation is true. If the equation is true, then yes, this is a solution. If it doesn't come out to be equal on both sides, then no, it is not. So for our first example, we're going to take the equation 4x minus 3y equals -1, plug a 5 in place of the x, plug a 7 in place of the y, and work this out. So 4 times 5 is 20. 3 times 7 is 21. 20 minus 21 is -1, which is what we say the equation should equal at the end. So 5, 7 is a solution. So the answer is yes, 5, 7 is a solution. Now we want to know, is 2, 3 a solution to the equation y equals 3x minus 7? Again, we have an x and a y, so I'm going to plug them both in where they go. The y becomes -3, the x becomes 2. 3 times 2 is 6. 6 minus 7 is -1. In this case, the two sides are not equal, so this is no to -3 is not a solution. The reason these are called linear equations is because when they are graphed on the coordinate plane, the solutions form a line. And we're going to see what we mean by that as we graph this particular equation. When we're graphing equations, the axis that goes horizontally is called the x-axis. That is the direction in which our x values tell us to go. Positive values go to the right, negative values go to the left. The axis that runs vertically is called the y-axis. Positive values go up, negative values go down. So when we're graphing equations, one of the easiest ways to do that is to make ourselves a table and pick some random numbers. Now I know a lot of people have trouble picking random numbers because they want to know something definite to plug in. You can pick anything you really want as long as it falls within the stretch of our graph. 0 is an easy one to usually pick for the x, and then we'll pick another one after that. But first what we want to do is find the y value when x equals 0. So what I want to do is take the equation, leave the y, but this time I have an x value to plug in. So 3 times 0 is 0. 0 minus 1 is negative 1. So we know one ordered pair that works for this equation is 0, negative 1. Now to graph that, my x coordinate is 0, so I go left or right 0. I'm going to stay in the middle. And then my y coordinate is negative 1, so I'm going to go down 1 and put a point right here. Now to make a line I need at least one more point, so I'm going to pick another value. I'm just going to pick 1. Picking small numbers is usually for the best. So I'm going to start this whole process over again, rewrite the equation out, but put a 1 in place of the x this time. So 3 times 1 is 3. 3 minus 1 is 2. So this time I plugged in a 1 for the x and I got a 2 for the y. So my ordered pair is 1, 2. Come back to the center. My x coordinate is 1, so I go to the right 1. Before I put my point, I still have to go to the y coordinate. The y coordinate is 2, so I go up 2. So I went right 1, up 2, and I put a point right there. So my line then runs straight through my 2 points. You'll have to forgive the fact that my drawing is not perfectly straight, but it is rather close. And that's all you need to do to graph a line. So now we want to do it again. This time we have a new equation, so we're going to start with a brand new XY table. And I am going to pick random numbers for my x and y again. I'm going to pick a 0 to start off with for my x, but we're going to notice that that's not going to be the best of choices when we start to solve for y. 0 minus 2y is negative 2y. Now we have to divide by negative 2, but that gives us this ugly fraction, so I don't want to use 0. I'm going to try 1. 1 minus 2y equals 3. Minus 1, minus 1. Negative 2y equals 2. Divide by negative 2. We get y equals negative 1. So now we have a point we can graph. Right 1, down 1. So right 1, down 1. Right here. Positive 1 on the x, negative 1 on the y. Have to pick another one. 0 didn't work, so I'm going to guess evens probably don't since we're dividing by 2 to solve for y, so I'm going to pick 3. And again, you can pick whatever you want, but it's best to pick numbers that you don't think are going to land you in fraction territory because it's hard to graph fractions. So 3 minus 3 is nothing. We have negative 2y equals 0. Divide by negative 2. So y equals 0. So the second point we have is 3, 0. So we're going to go over 3, up or down 0. Right there's my second point. And we draw a line. And again, my straight lines aren't very straight, but that's okay. Sometimes when we're graphing these lines, it's best to use what they call the intercepts of the graph. The intercepts are the points where the graph will cross either the x or y axis. To find the x-intercepts, you plug a 0 in for y, solve for x. It will be of the form whatever you get for x, 0. There'll be a number here. To find the y-intercepts, you substitute 0 in for x and solve for y. So we plug a 0 in for x, and whatever we get for y is our y-intercept. The equation for horizontal lines is the form y equals a number, no x in this one. And the equation for the form of a vertical line has no y's in it. It's all x's. So we're going to graph a couple more. This time we're going to use the intercepts when we graph. So, well, if I could get this page to stop scrolling. There we go. Alright, so we want to find the x-intercept, so we know we're going to plug a 0 in for the y. As soon as we see the word x-intercept, 0 in for y, and work it out. So I come down here, plug a 0 in for y. 3x minus 0 is 3x. Divide by 3. So x is -2. So there's one of my points. Now the x-intercept should be crossing the x-axis. So I'm going to go 2 to the left and 0 up or down, and it does. It hits the x-axis right there. Thus the x-intercept hits the x-axis. For the y-intercept, I'm going to plug a 0 in for the x. So I work this problem out again, but I plug a 0 in for the other variable. 3 times 0 is 0. So 0 minus y is negative y. To get rid of the negative on a variable, I divide by -1. So that just makes it positive y equals positive 6. So I plugged in 0 for x, I got 6 for the y. So the y-intercept should hit the y-axis. So let's make sure we do that. The x-coordinate is 0, so I don't move left or right at all. The y-coordinate is positive 6, so I move up 6, and right there I am exactly on the y-axis. So there's my x-intercept, there's my y-intercept, and the line that connects them is the line for this equation. I'm going to do one more of these, and that should do it for this particular. Well, we'll do two more, one without a y in it. Okay, so again, x-intercept, plug 0 in for y. Y-intercept, plug 0 in for x. We know we're going to do both of those things as soon as we see both of those. So if the x-intercept, we're plugging a 0 in for y, so 4 times 0, we're having problems here with the pen, there we go. Four times 0 is 0. Come on, ink pen. There we go. So 6x equals -12. Divide by 6. We get x is -2. So we're going to go left 2 and up or down 0. First point right on the x-axis like we wanted. I'm going to come up here and do the y since I ran out of room there. So I'm going to plug a 0 in for x this time. So 4y equals -12. Divide by 4. Y equals -3. Oh, bother. There we go. -3. So we're going to go left or right 0, down 3 since it's negative, right on the y-axis. Line goes straight through. Now up to this point we've had both an x and a y intercept. Now we will see that sometimes one or the other may not exist. There we go. So remember, for x-intercept we want to plug a 0 in for y. There is no y in this equation. Notice the equation 5x equals negative 20. There is no y to plug 0 into. So I just need to go ahead and solve it. So 5x equals negative 20 divided by 5. X equals negative 4. So we know we're going to go through the point negative 4, 0. Now here's where it gets tricky. I could plug a 0 in for x to get my y-intercept. But if I do that, 5 times 0 is 0, and 0 does not equal negative 20. So I don't have a y-intercept. What I do have is an equation that simplifies down to x equals a number. Well, remember from before, if x equals a number, no y's in the equation, that means it's just a vertical line. A vertical line just goes straight up and down. So all I have to do is go straight through x equals negative 4. Now we can only do that when there's no y's in the equation like there are here. If there was a y here, I would have been able to solve it. But since it's just x and numbers, I know it's going to be a vertical line, and it only has an x-intercept.